The identity is.
Wait, hang on a second. Now, you know all this new material is gonna be on the final exam. So all of us, I mean all of us, would like to do really well in that final exam. And I'm working on a review for it. To get that to you pretty soon, okay? We've got a little time before that final exam comes up. This is it, guys. Exam 5 tonight, and then a little homework check, and you got that final exam coming up and a little extra credit. Yes?
Will there be a homework check for the?
Not the final exam, no.
Oh, okay.
This is the last homework check. Okay, Jacob, go for it. Establish what?
Secant of theta times sine theta
Hang on now, okay?
equals tangent theta.
And guys, what they want, I started out with one that's fairly basic. Notice it does not say solve. You're not solving this. They're asking you to use, they use the word establish. They're saying, can you show me that this is a true statement, in other words? Can you use something that you should realize from previous work, make it simple, make a little substitution maybe, and show me that these two sides are the same. Matthew, what do you got in mind?
Secant is equal to 1 over cosine.
Hang on now. So he says, Professor, if you quickly show me this, and that's one of the basic trig identities, and
Then you multiply by sine.
okay, let me leave that sign in black there so I can show the students I'm not messing with it. And he's telling me, Professor, you got this with that blue substitution, and I know, and we all know, this is tangent. And you're finished. That's it. I just want you to show that that is a true statement, and I did. Now, do they get a little lengthier? Of course they do. Jacob, what's the next one?
B is parentheses sine theta plus cosine theta
Okay, hang on now. Okay,
squared
okay.
plus sine theta minus cosine theta squared
Hang on, okay.
equals 2.
They want you to establish that. Using some basic identities we've already used in class. To get us started, I'm going to expand this thing out first. Now be careful, guys, when you square this, it's not just sine squared plus cosine squared. There's a middle term. So we end up with sine squared plus 2 sine cosine, I think, plus cosine squared. Let's see if everyone agrees with that expansion of the first term.
Yeah.
Now, if I expand the second term, this one, I'll put it in a different color, you end up with sine squared, subtract 2 sine theta cosine theta, plus cosine squared. Step back, guys, and see if you agree. And that color, is that expanded correctly?
Yeah.
Now, if I take a close look, we know this term will cancel. I see some like terms be put together. I see 2 sine squared terms. Mine plus looks like 2 cosine squared. And I could take out a common factor of 2. Make this look really nice. And all of a sudden, we're going to something I recognize, which is what, 1?
Yeah.
And 2 times 1 is equal to 2. And you've made this established. Okay. Now, were those the only 2 I had there?
There's one more.
Beautiful, hang on now. This one might be a little bit more difficult than the last one coming up. Read that to me. Jacob.
Secant theta
Okay,
over cosecant theta
got you.
plus sine theta
Okay,
over cosine theta equals 2 tangent theta.
got you. Okay. Now we'll do this. Should have done it on the others. I like to do this just to show this is not an equation. I'm trying to solve it. Just trying to show the 2 sides are the same. trying to establish. Looks like the left-hand side is where you're gonna work, if anything at all. Matthew, go for it.
Okay, so we can change, the secant or the cosecant to 1/sine.
Hang-
So
one over
it's 1
cosine.
over cosine.
Hang on
1 over
now.
cosine
Got you.
over 1 over sine.
Absolutely, one of the signs.
And then we can inverse, and then we can simplify.
Hang on now, but you guys should be neat. Show me you have not done anything with this one, this term. Okay, now he says, Professor, if I clean this up, is this sine over cosine?
Yeah.
You're doing the math there, so this in the blue is gonna be sine over cosine. And it looks like it's gonna be plus a sine over cosine. Matthew, is this what you had in mind?
Those are both.
Thank goodness, combined like terms, you end up with 2 sine theta over cosine theta. Now they want this. Could I now write this as 2 directly tan theta? Is this tangent here? Yes or no?
Yes. Yes.
That's been established. Now, have I seen some of these run 15, 16 steps to make the two sides finally be the same or steps? I have. Okay, that would not be appropriate for us right now because that's way, way too time consuming. But I've seen some that will take quite a few steps to show finally it's a true statement or it's been established. But guys, that's what they mean for identities, just show the two sides are the same with the help of some previous work. Tell me, Jacob, is that the end of that section?
That is indeed.
Okay, hang on. Now guys, this one, as you see, when you get triangles. If any student, I think most of my students, I've done a little research on all of you. I think most of my students have witnessed, have seen trig back in some school. And more than likely, when you saw it, you used something with triangles. More than likely, you did not work too much with the unit circle. You probably worked a lot with the triangle. The right triangle involved here on one side, and the other side looks like it's a different type of triangle. So guys, that's what chapter 7 is all about. Let me make sure all of this looks good. If not, we got issues. Now you guys will tell me this does help when you see this.
Absolutely.
It's best out. I guess, can you imagine the final exam, if I were a student, I'd just make sure I would keep all these. And just go through and say, oh, I remember doing this, remember doing that, in preparation for the final. Nathan, are you up to it tonight?
Yeah.
Can you do this?
Oh,
Yeah, that's the original one, that was on top. I gave it to me. Mr. Park, we've got some more. Got 2 students over here. We have plenty of copies. Okay. Jacob, we, the class, myself,
Yeah?
read the written binding.
Oh.
Now, here we go. It's chapter 7.
Chapter 7 or continuation of chapter 6.
Well, first the continuation.
Yeah.
Guys, chapter 6, this is where I sort of stopped Monday. You guys were with me, we certainly we saw most of that. But then I thought, wait, we're not quite finished with that particular chapter, chapter 6. So there's a little continuation to finish it up. Jacob, tell us, how are we going to close down?
So we have to establish the given identity.
Hang on now, going back to establish. And everyone, statement, do they want established?
Cotangent theta minus tangent theta over cotangent theta.
Okay, hang on. Over cotangent?
Cotangent theta plus, no, on the
Oh, I
bottom.
got you, mine's here, and then plus on the end, bottom part.
Yeah.
Denominator.
Cotangent theta plus tangent theta
Okay.
equals cosine double theta.
Now this is where it is, cosine double theta.
Yeah, cosine 2 theta.
This is where we get into, do you really know your pre-calc? That's why I did this first. These just fell right into place. These were established. Now we're trying to establish these two sides are the same. They, at this point, look nowhere near the same. Does anyone have an idea what could I do to start on this one? In the attempt to show, Professor, they are the same, the two sides. Matthew, go for it.
You could put them in, cosine over sine.
Okay, hang on now. You asked me, please, we'll call step one. Change cotangent into cosine over sine. And I'm assuming you're asking me when I reach tangent, change it into sine over cosine. Matthew, do you have in mind also to do the same thing on the denominator?
Yes.
Cosine over sine. And of course, plus sine over cosine. And guys, please keep in mind, as you do this, and on the final exam, I do recall I have a challenge one to give you guys. But right now, this looks nothing like this.
Cosine 2 theta is cosine squared.
Well, let's stick with one side first, and then I'm gonna take your suggestion though on the other side. What else gotta do besides what you see right now on the left?
Give them
Common denominator. Let's put the two terms on top together with a common denominator, what? Sine, cosine. I'm going to put that common denominator here. Nathan, if I'm trying to combine those two terms on top with that common denominator, that means I have to multiply this one by cosine.
Yeah,
And this one by sine.
yeah.
So we end up with cosine squared. When I do that, subtract sine squared.
Yeah.
And all that's over my common denominator, and we're not quite finished. We gotta do the same thing down here. Combine these two terms in my denominator. I think the same denominator here, sine, cosine. And guys, I'm assuming if I want to sine, cosine, multiply this one by cosine, this one by what? Sine?
Yeah,
So we end up with cosine squared
plus,
plus sine squared.
can we change that to
Yeah,
one?
but you gotta be careful now, just one thing at a time, you gotta be neat on these. Step three, run out board space and bring them here. Absolutely, I think I'm hearing cosine squared plus sine squared, Professor, is 1. This up here is nothing right now, but I think, Sophia knows what it is, but we're going to leave this the way it is for right now. Marker here, sine theta, cosine theta. And I think you guys are saying, please go down here, Professor, and get this done, which is 1 over this. Is it true? At this point? Now, what's gonna happen at this point nicely for me?
Sine theta, cos theta will cancel out.
Yeah, step 4, if you take a close look and do your algebra, these are gonna cancel. And you're gonna merely end up with cosine squared minus sine squared. And you guys who were with me on Monday, I think that was a formula for it. I think I gave you 3 formulas for it. I think that was one of the formulas for this.
Yes.
Yeah, wasn't it?
So if you get to that point, you're saying cosine double theta, Professor, is equal to this, and you stop, I'm good. I see you've already worked down to the point where something has been established, and we're finished. Okay? Now, if you want to, I think Sophia wanted to, she said, Professor, would you mind if I go ahead and just jot down over here? Yes, this is this, on the right. And that would be a little better to show finally they match up. They have this established. Yes, sir.
Did we do the little box thing with the three like hashes or like the EOC or something? Like,
No.
As a proof?
No, we're good. Okay. Jacob, tell me
One more.
more.
We have one more that we need to establish.
Okay, hang on. Are you guys good with this one? Where are we to establish next?
Cosecant double theta
Hang on.
equals 1/2 secant theta cosecant theta.
Nathan, class, if I were looking at that, those two sides look nothing alike. We're trying to establish they are identical. I need some help here. Now keep in mind, you may choose which side you want to work on the left or the right, and try to transform it into the other side. It's up to you as to which side you want to work on. Jacob, go for it.
Could we try and work on the left side and transform?
Right here?
Yeah. And
You
use
couldn't change this to what then?
1 over sine double theta.
We'll do that right now. And those guys, by the way, they do not ask us to give a reason. Just write down. Don't say this came from this. Just write down the statement. You guys agree with that, guys? Guys, that's called step one. What else could I do? Yeah, what's the double angle formula? I know you saw it on Monday. What's the double angle formula for sine?
Isn't it?
Sine theta, cosine theta.
Absolutely. And I think with that start, guys, if I look over on the other side, I think this is it.
Yeah, that's right.
You've established this. I'll leave it written the way he gave it to me. Well, not quite yet.
Because now.
Now what? Yeah, we're not quite there.
Now
You just rewrite the secant theta and cosecant theta.
Now, you want to do that here and then show they match up?
Yeah.
I wouldn't mind that, but I'd prefer if you could just stick with one side, don't move to the
Okay.
other, and try to get it directly related to the other side. So we'll stay on the left.
Well, you could rewrite it as
So
1/2
One and a half,
times 1 over sine,
love it,
and then 1 times 1 over cosine.
love it. That's all it takes. And if you want to write this all together, it's 1/2. What was that, secant, cosecant? I may have mine turned around. What was it, cosecant?
Cosecant.
Secant. And if I saw that, guys, as an instructor, he said, Professor, can I stop there? I can see right now it matches up. You guys agree? As long as I get those two sides to match up. Now, Laura, I've seen some though, where they're so difficult to show they are the same, to be established, that all of a sudden you work on one side, and you do everything that you possibly can do, and it does not match up with this side here. And then guess what you have to do? You get desperate, and then you come over here and you have to work on the other side. So I work this down to a certain point and say, Professor, it's not matching up to the other side. You can stop there and say, I'm gonna move to the other side then, work on it, and maybe now they'll match up somewhere down here. That can happen. Okay. Jacob, was that the last?
That was the last of establish the given identity.
Okay, was there now something else on that?
There's half angle formula.
Did I list those Monday on there?
You listed
This
them
is on the
there,
new
but
sheet,
not on
this is the
Monday.
new sheet. Okay, here we go. Part 3. Guys, the last set of formulas, half angle. Mr. Park, since you've already gone through Math 7, you're Math 8 now, and making his top student in his class. Do you recall, did you guys have to use some of this trig either in Math 7 or Math 8?
Yeah,
Did you have to use, maybe, did you ever run into a double angle formula in Math 7?
we use double angle, half angle.
Okay. Okay, now, did I just list what they are?
Yeah.
Guys, I wish I had the time to show you where they came from. Because I know some students will say, Professor, you showed me where it came from, and I may forget, I can't memorize this formula, but I may forget the formula, but I'll remember the derivation. And I'll sit there and derive it myself. So there is a way you could get this, but I think I just listed them. What's the first one?
Sine 1/2 theta
Hang on. Okay.
equals the square root of 1 minus cosine theta
Okay.
over 2.
And all that's underneath the large square root.
Yes.
Did I put plus minus in front?
No.
I'm gonna put a plus minus, just play it safe. Did I also give another?
Yes, you did.
Okay. Cosine?
Cosine 1/2 theta equals, didn't put plus minus, but I'm gonna say plus minus.
Absolutely.
Square root 1 plus cosine theta over 2.
Did I give one for tangent?
You did not.
I did not. Is there one for tangent? Yes. There's a formula. I didn't give it to you though. Is there one for secant, cosecant, cotangent? Yes. Ignacio, if I did not give tangent, even though some students will go to the textbook or somewhere and find the formula, if you use it, I'm fine. Right now, though, at this point, suppose I ask you to find tangent for some reason, using what you see right now.
Sine over cosine.
Just put sine over cosine. Put the top formula over the second formula, and that's tangent. May look a little messy.
So you would put like that whole thing?
The whole thing.
Over the whole thing?
All this, over all this.
How? Okay.
They'll turn into tangent. And when they do this in the derivation, they probably have to put that over that. They clean it up. And then they show you what the formula looks like.
Okay.
Okay. Jacob, how about some exercises now?
Cosine
Hang on now, cosine.
of pi over 12 equals blank.
Now, here's the issue. This is the reason I did this. Hang on. If I ask you to find cosine of pi over 12 on the final exam, and I think pi over 12, I'm converting that to degrees real quickly, guys. I think that's like 15 degrees. Some students, wait, Professor, we've done this one before with another formula. So if I don't specify which formula, some students will say, Professor, if this is 15 degrees, could you not write as pi over 4, subtract pi over 6?
And then you
Step back, hang on. Is that the same?
Yeah.
And then use the what? Cosine A subtract B
Subtract.
formula from Monday. I'll tell you, these formulas are gonna catch up with you. You can now use cosine A subtract B and you'll get an answer. Why did I bring this in under the category half angle? Matthew's gonna tell me. Now guys, you can do it this way. Now by the way, if you do it this way, the answer coming out is fine. It may not look like though what may come out when I use the half angle formula,
You can essentially.
but they are the same value. Tell me what I could do,
You
Matthew.
can essentially factor it to be cosine 1/2 times pi over 6.
Oh, this is that. Cosine of 1/2, he says, Professor writes this as 1/2, I'll put the time symbol. He wants pi over 6. That's pi over 12 altogether. And he says, Professor, I've made this look like this. Therefore, my answer by half angle formula will be equal to either plus or minus, we'll decide which one's here shortly, square root 1 subtract cosine.
wouldn't it be 1 plus?
Where was it? Oh, we're doing cosine. 1 plus cosine all over 2, and I'll hold up on that plus minus.
Wouldn't it be 1 plus cosine?
Pi over 6.
Yeah.
Is this true, guys? And then if I finish this up, we end up with square root of, here we go, 1 plus, what is that, radical 3 over 2 or not?
Yeah, right 3 over 2.
Cosine pi over 6.
That's right 3 over 2.
Okay. All over 2 underneath there. This is where some of my students will mess up. Clean this up. Combine those two on top of the common denominator, what, 2? End up with 2 plus radical 3 over 2, still underneath there, over 2. Bring it up here so you guys can see it. Guys, we end up with square root, a large square root. Looks like it's going to be 2 plus radical 3 over 4. Is that true?
Yeah, we can take out the 4.
Absolutely. Leave the top as it is. And Jacob sent me Professor square root 4 is a 2. Look at that strange answer. I guarantee you, my students who would choose, if I did not tell you which one to use, if they chose this one, Nathan, and go through a formula for cosine A subtract B for Monday, your answer's going to look nothing like that. But they're equivalent.
Oh.
I am telling you, they have the same value. These solutions out tonight, if I should ask her to go to a calculator and calculate both, she'll say, "Oh, Professor, the screen shows they are both the same value. They don't look anywhere alike, anything alike."
Are they, is there something, are either of them preferred in
It
later
depends.
division classes?
Depends on
or-
the situation.
Okay.
Physics uses this, they may ask you to use the half angle formula
Okay.
rather than A plus B or A minus B.
And then we choose that it's positive, right? Because it's in quadrant 1.
Oh, beautiful. Now, you say, "Professor, you held off, you know, with plus or minus here." I noticed it's what, the original angle was 15 degrees. It's in quadrant 1. And everything's positive in quadrant 1. Also, thank you. It's right here, positive. Okay, guys, look at that strange answer. I wish she was here because we could do it both ways and compare, and you'll see the values are the same. Jacob?
Mm-hmm.
We did that one example with a half angle formula. Now, what else is there, if anything?
Cosine,
Hang on. Okay, cosine,
22.5 degrees. Equals blank.
okay. Guys, this one definitely going to use a half angle formula. Now, I'm saying half, it's got to take you back to an angle you recognize. Half of what angle that we used before is 22.5. Yeah, 45. So this is in degrees. So let's write this as cosine 1/2 of 45 degrees. And then I must use the cosine. Did we use cosine 1/2 earlier?
Mm-hmm.
Oh, we're using it again. I want to do the sine. Okay, we'll use this one. Thank goodness, guys, we're in quadrant 1 since we have positive. Same thing here, same routine. Square root, what was that? 1 plus cosine 45? Make sure I get everything in there correctly. All over 2. Square root of, you all know what cosine 45 is. Radical 2 over what? 2, all over 2. Now, can someone in this accelerate class without me going through every little step? Anyone tell me what this finally comes out to be when you cleaned up?
Root 2.
2 plus
2 plus.
root 2 over
2.
Are you saying it like that?
yeah 2.
Hmm. What a strange answer. And by the way, Sophia, I don't have right now another formula I could refer to. I can't use A plus B on this one. I'd have to use a half angle formula. Anything else there, Jacob?
Not related to that. We are now on to chapter 7.
We are?
Yeah. Right triangle trigonometry.
Whoa. Okay, guys. Before I jump into it, because chapter 7 is going to move fast. Any concerns about this? You guys had a couple students out Monday. Guys, when you're out, you're going to have to send me an email. Because their counselor, SMC, is sending me emails about attendance. If you're not showing up, I have to report to them, student so-and-so was absent. Student so-and-so was absent. So please, if you have to be out, email me. Let me know. It might be a good reason why you're out. But make sure you let me know, because the SMC's on me then for attendance. Jacob, you're saying we're going to right triangle trigonometry.
Correct.
Hang on. And we'll get this chapter 7, a lot of it done tonight. Well, guys, I appreciate my class. I appreciate the effort you guys have put in, but we could not have done this without my two assistants and with these handouts. This is the first time I've done this with the handouts. The first time I've condensed each section and handed it out. I've given handouts, of course, but not like this, as detailed. I'm gonna start out like part one here, Jacob, and you're gonna help me out here, but before I jump into it, let me do this. He tells me, Professor, they're turning this into a right triangle trig course. In other words, they're taking us back across the street. They're now taking us to the middle school.
So, how?
Yeah, I told you the story about that. But here we go. We are accustomed to this. Your textbook says, no, do the unit circle first. We did. And we did a good job on the unit circle. And we had something like this to work with. We took a look at points on that unit circle. So guys, I'm gonna label a point right quickly. I'm gonna label it as X, Y. I'm gonna draw the terminal side and form an angle like we've done before. And then we'll have the angle to look like this. And I'll get out of your way here. Like that. And I'll sort of set you up. I think many students would say, now, Professor, could I drop a perpendicular and form a right angle?
You sure?
And then move into right triangles, like we did back in middle school. So if I do this, and this is what that right triangle trigonometry chapter 7 is all about. We're going to mark this as a right angle. Now guys, on my triangle that we're accustomed to, since I've already marked that point with X, Y coordinates, I know and you know, this side is X, this side is Y, I'm squeezed in here. Is that true? That's what the point means. The other hypotenuse, they call it, the black, we have been accustomed to as that's the radius. And in fact, we want it to be 1. And some of my exercises before we got into chapter 7, we changed it into a 1 if we had to. We're accustomed to a unit circle. Now they're saying, well, open it up. Let it be any size radius. So I'm just call it now, not 1. We'll call this black segment here, R, radius. And then run through and redefine the trig functions with that set of X, Y, and an R for radius. If I do, before I jump into that though, you guys from middle school, more than likely, and they do in the textbook here, they also identify the X, the Y, and the R. And I did this just so students could remember by using this. They're saying this Y that you have here is actually opposite the angle that you're concerned with in the corner. So they call this the opposite side. They also, for students, especially in middle school, they give a name for the base down there, the X. And some students may recognize what that was back then. That was called the adjacent side. And of course, we all know that this is the hypotenuse. Is that true? We've got an opposite, adjacent, hypotenuse, and they did that most part for just students to remember this. Now, with that said though, Matthew, I'm gonna go back through and remind you of the 6 trig functions. Let's start with sine. You say, Professor, sine was y, wasn't it? Could I rewrite, to get into what they want us to do now, could I rewrite this as y over 1? Is that still y? What do you think that one was representing? That I did not place there when I gave you the definitions. But you could write y as y over 1. What do you think that one was representing? That the hypotenuse was 1. It was a unit circle. So now they want you to change it into, let's put a comma here, sine. Let's think of it as y over r. And then if you want the words there, y was what? The length of the opposite side, guys, just to make it. Absolutely. Just to make it brief. So I have lots of time here, not too much time tonight. Over the hypotenuse. So it's opposite over hypotenuse. Cosine earlier was merely x for us on the unit circle. That was like x over 1. We say now let's expand this and write cosine as x over r. And this is now going to be adjacent side over hypotenuse. Number 3, we did tangent. And the old definition for the unit circle was merely y over x. This was nice. That means for now, we're going to do opposite side. So which side was that? Over adjacent side. More than likely, let's call it hypotenuse. That is the way you guys probably saw this for the first time in your life. Is that true? Yeah. And then I'm hearing, which I had never heard before, and I told you the story when I did this. Some students that get, like Jacob just said, SOHCAHTOA. I had not heard that. So some students in class, when I got to this with them, I heard that, and I said, are they calling me a name? Someone angry with me? They're calling, I don't know what SOHCAHTOA meant. It didn't sound too friendly. But it's SOHCAHTOA, right? Jacob, since you mentioned it, yeah, I'm trying to remember the initials here.
SOHCAHTOA. SOHCAHTOA.
Yeah, and I've observed students in the hallways of high schools. I used to go to Proctor, the student teachers. Oh, they'd walk through the hallways. With a smile on their face, Matthew. That meant they knew what they were doing, I guess. Okay, so that would just sort of help you with the initials there to remember what is what. But that's what it'll come down to, though, I think. Did I have a triangle or two there to solve?
We did. We have 2 triangles.
Now, hang on. Here's the issue. To get through this. I don't have Susan with me tonight. I think these would require a calculator to find certain missing parts of that triangle. So the best I can do right now is to set it up for you. And maybe on Monday, we might, if you remind me, we'll have her to calculate and show us what the values should be. But at least we can set it up tonight with the help of these new definitions. Jacob, on the side here, I know it's supposed to be a right triangle. Did I have the angle, the right angle here or on the other side?
You have it on the right side.
Over here. Okay. And I'm assuming it looks something like this.
Correct.
Now, did I have anything labeled?
You have the top angle labeled as capital A.
Okay, now hang on now. So this is A,
Yes.
capital A, okay, number 1.
Then you have the right angle labeled as C.
Right here.
The line AC is
Okay,
labeled
yeah,
as
I'd be over here probably.
Yeah, and the opposite of B is
Now,
look.
I've got some lowercase letters. So after you label, it's up to you as to how you label the capital letters. But after you label those, then what? The sides opposite are labeled with the lowercase letters by convention here. We just do it in math. So capital A is here, so opposite A is lowercase a. Capital B representing the angle in that corner, lowercase b here, and of course lowercase c on the hypotenuse. And we have something like that. By the way, guys, does that one just stare at you right there and say c squared is equal to a squared plus b squared? Is that what that says? Of course it does. Now, did I give some values?
You didn't need. You gave lowercase b is equal to 5,
Here we go,
and uppercase b is equal to 20 degrees.
down here.
And that's it.
That's it. And when they say solve that triangle, they want you to find all the missing parts. No issue. I don't think this will be any issue for any of my students. If they say found the missing parts, guys, you know and I know, all three angles in a triangle should sum up to 180. Or I know two of the angles already, the 90 and the 20, that's 110. So quickly I can say what? Angle A must be 70 degrees. That part's out of the way. That's no problem. All the three angles should sum to 180. Now, I've got some missing sides. Guys, I don't care which one you find first. I'm trying to find, so I'm staring at it. Let's try to find side A. They gave me B. Let's try to find side A. Does anyone have one of these new definitions that I could use to set up in an attempt to find lowercase a or segment BC? I see hands going up. Let me go to Nathan right now. Okay.
So, wait, how did you find A?
I haven't found it. Oh,
So
right here,
you
all
always
three
said-
angles should sum up to 180. So this is 90, this is 20,
Oh,
that's 110, so we're looking at 70.
Okay, thank you.
Jacob,
I would use the tangent property.
now if I use tangent, you want me to show the opposite over the adjacent.
That's correct.
Okay, so let's take tan of 20. And take the opposite of the adjacent. The opposite side for 20 is the 5. And the adjacent has been labeled with the A. Do we agree? And then mere cross multiplication, guys, and clean this up, you will end up with something like this. And I think A will be equal to, this is where I would need her help. I know, but I'm gonna come up with a value here. So it's 5/10 of 20. So if I had a calculator, I could just create that on a calculator and find 5/10 of 20 and get the angle, and I don't have the value right. Does anyone have the value? No, okay. So we'll just leave it like that. Number 3. That one's out of the way, guys. That's side A. We got side C. Yes.
I would use the sign property.
You mean the C squared is equal to A squared plus B squared, or your sign definition?
Sign definition.
Okay, sign definition, if you want opposite of our hypotenuse, and you want to take sine of what, 20?
Yeah.
Okay. And that should be opposite of our hypotenuse, 20, the opposite's 5 again. And the hypotenuse is labeled as C in this case, and he's correct. And if you cross multiply, guys, and solve this, all of us can do this. C is equal to what? 5 over sine 20.
For 5 over tan 20 is like 13.7.
Which one are you looking at now?
5 over tan 20 degrees.
Oh, you did this one for me. Sophia, tell me what was again? What was it?
13.7.
13.7. Sophia, do this one for us. 5 over sine 20. 14.6. Thank you so much. Okay. Now, do we have all the parts missing? Did we find all the missing parts with these new definitions? I think I did. Sophia, do me a favor. In fact, I can sort of estimate. If those values are correct, C squared is equal to A squared plus B squared should be valid. Pythagorean theorem. So if this is the correct C, I need to square that. Square that 14.6 for me.
It's like 213.7.
213? 213 something, okay.
And like when you subtract 20.
Hang on. So C squared is equal to A squared plus B squared. We found A earlier to be 13.7, she says. And of course they gave me B, that's what, 5? Sophia, see what 13.7 what it's close to squared. Right, 170 something?
187.
Oh, 187?
188.7.
188.7. I know this is 25. Now, if you add those two up, we're because we estimated. We're close to 213.
Yeah, 213.7.
Beautiful. Okay, so those values should be okay then. There's no issue there, is there? Opposite of a hypotenuse, all that business? No. Okay. Jacob, what's the next one?
You have another right triangle.
Hang on. Gotta check my time here. We're gonna get through most of this. Now, as we're erasing this, you'll see in the final exam. You say, Professor, how are you gonna tie all this in together? You'll see something like this. Natural log. Oh. With maybe this. Right? Then maybe this.
And then you're gonna put a natural log in there.
That's something else. Yeah. Look at that mess. I put everything together in one problem.
You're gonna raise it to X.
Oh, I could raise it to X, right, I could raise it to X.
It's been a great year.
It's been a great year. Okay, Jacob, tell me what that last one is.
The last one is another right triangle.
Okay, did I have this one to sit the same way or not?
No, it's sat the opposite.
Okay, thank you, hang on. Something like this. And this. Sophia, I'm gonna ask you to give some estimates here shortly.
The top is labeled B.
Okay, this angle up here is angle B.
Yep. C
This
is
C.
the, yep, and then A is the remaining one, and opposite all of them are the lowercase.
Thank you.
The given information
Okay.
is A equals, lowercase a equals 2,
Oh, 2, okay.
and lowercase b equals 8.
8. And they're asking me to find the missing parts. Nathan,
Yeah.
I think as a student,
Mhm.
I might say, oh my goodness, I see one part I could find even from middle school right quickly. That's missing, is that hypotenuse. C squared is equal to what? A squared plus
B squared.
B squared, and it not involved in your trig function. We're going to end up with C squared is equal to, he gave me 2 squared plus, looks like 8 squared. Guys, so we end up with 4 plus 64, is that 68?
Yep.
Take a square root. We all know what it looks like when you simplify it. It's 2 radical 17. Sophia, we're going to just leave it like that for right now, for that one. Are we okay, guys?
Mhm.
Laura, I'm gonna get back to you. Okay. That's done. You mark this, that we discovered this is 2 radical 17. Now we got some issues. Angle A and angle B are missing. The right angle, does that mean angle A is 45 and angle B is 45, and therefore all three would add to 180? Or maybe angle A is 60, angle B is 30, and then therefore all three would add to 180? No, there's lots of combinations there. I'll still go for it.
I would just use the tangent, the formula.
Okay, you want tan of angle A or angle B? What's up to you?
A.
Okay, so take tan of angle A. And I know tan, new definition is, that's what he wants, whereas opposite side over
Over adjacent.
adjacent. Well, the opposite side for his angle, he's using angle A, the opposite side is 2.
Over 8.
And the adjacent, what was it, 8? So this is a 1/4. Now that's tan A, we want A. That's tangent A. Sophia, I need some big time help. Now first tell us, how are you going to approach this to find angle A?
Inverse tangent.
Thank you. We're going to apply an inverse on that 1/4.
14.0.
14 point something?
Yeah.
Is it supposed to just 14? Okay. So we'll say that's 14 degrees. And that was for this. Okay. I have one more, I think that was angle A. Put that one out of the way. We have one more, what is it, angle B, missing. Matthew.
I mean, before we have, we can just subtract, 104 from 180.
Now, let me tell you the risk on that. What you can do. Absolutely, you can do. Just say you have two angles, sum them up, subtract from 180, since all three should have to 180. The risk is on that, and more than likely, most of the time it works. The risk is if you made a mistake on this one. If you made a mistake of some sort on this one, and then you carry it into finding the next one by doing what you said, subtract from 180, you're going to miss it also. So I'd prefer another maybe function to try to come up with angle B.
We can use sine.
Matthew, try it again.
We can use sine.
Okay, you want sine of angle B? Hang on now.
Yeah. And that's.
Well, hold on. And I know by this new definition that's opposite over what? Hypotenuse?
Jason.
Hang on. Is that opposite or hypotenuse?
Yes.
That's scary.
That would be 8 over
8 over.
2 root 17.
Now, Matthew, what you've given us, perfect.
Just gotta,
That has to, you got to clean it up.
yeah.
Now, see right now, 2 goes into 8, 4.
It would be 4 root 17 over 17.
This guy is so quick with these. Have you noticed in class guys how quick he is? One of the quickest I've ever seen. How he rationalizes these things. Now, Sophia, you're gonna have the hard part. You gotta do an inverse sine. Find out what B is. Oh, that's strange. You may want to approximate that 4 radical 17 over 17 first, and then do it.
75.9.
Oh, you got it. 75.9 degrees up here.
75.96.
96? As long as these two will add up to, these two should add up to 90. Am I close? Of course I am. Now, have I found all the missing parts?
Yeah.
Yeah, with these new definitions. Okay. What's next?
Next, we have law of sines and law of cosines.
I'm so glad I did this. Just wait, Professor. I follow you so well on this Sophocles, of this new method here. What on earth are you talking about now? Wait, and this may take me up to the break. Before I jump into what he's called law of sines. Laura, what is that question?
It's just like, you use a calculator to have like to get the results.
What's that? Now you have options. Are you telling me that you may not do it exactly the way I did mine?
No, but like, how would you find it better if we're not using calculator?
No. Guess what I have to do? Someone in this accelerate class tell me, on the final exam, no calculators, and all of a sudden you have a triangle to solve. Where
Yeah.
Sophia's been nice enough to help me, but no calculators. What must I do as an instructor to still see that you understand how to do this, but you can do it without a calculator?
You can use it.
I've got to give you a 30-degree angle, or a 60-degree angle, or a 45-degree angle. I'm limited. Okay, then you could do this using those special angles. I can't give you like I did up here, the 20 or what else was it?
79.
70, whatever. I can't do that. Okay, that's the same routine, but you'll have special angles to work with. Okay, Jacob. Before I jump into it, it may take me all the way up to the break here. I think we've done a good job, though. Hang on. Nathan, since you're close by here, you're going to help me to do this.
Uh-oh.
Before I jump into law of sines, look at my time here. I got 9 minutes. This is one I need to derive. I need to show you where. Did I have 3 versions of that, or just one version? What did I have it written down for you?
Yeah.
Did I have it sine A over A
Sine B over B.
and sine C over C? Now, so say you walk in and you say, Professor, I have enough formulas to remember as it is. I'm gonna get all these formulas mixed up in my head. I can't keep all this stuff straight, and you're not gonna allow a sheet of paper to be used with formulas on it, are you, Professor? No. So you may say, well, I've forgotten. I want to do this first, and we'll take a break. Let's go into another triangle on the side here. Guys, I hope you're copying all this down. Now, I've done something unusual. This is not a right triangle. And they give a word for it. If it's a non-right, does not contain a right angle, like the others did, they use the word, this is an oblique triangle. Non-right, no right angle. But I'm gonna label it like this. A here for that angle, B here for the corner, C here for the angle inside, then the lowercase letters opposite, lowercase a, lowercase b, lowercase c. One of my former students said this was the best part of the course for him. Of course, I had him 3 times. I'm telling the truth, 3 times. Are you still enjoying this? Okay. I got the lowercase letters. Now, I want to express, if I can, let's see a good way to do this, oh boy. I like to express the area of that triangle to close down before we take a break. How do you find, since we're talking about triangles today, how do you find from middle school the area of any triangle? That's a basic formula. I hope we remember what it was. 1/2 base times height. Is that true? I walk across the street, those kids should know it. 1/2 base times height. I like to express, using that formula, the area of this oblique triangle. The trouble is, I have a base. My base has been marked with letter C, lowercase c. That's my base. What's missing? The height. If I intend to use that formula, I miss a height. Let's drop a perpendicular down to the base, and now label that with an H. And I'll feel good when I get this finished. Now I have a height. Is that true, guys? Now I'm going to go back and see if I can express now, some way, the area of this triangle. 1/2 base times height. I'm going to repeat myself. Base is what, C? So I could say this is area is equal to 1/2 the base. I know it looks like the letter C is being used for the base. Height. Is that true? Base is C in my case? Okay. Height is H. Now, step 1. Step 2, watch carefully. I'm going to close this down. When I drop that perpendicular, do I now have 2 small right triangles inside there? I want to do something with them. The one on the left, the small right triangle here, I like to express the sine of, for a reason, angle A. And it's inside a right triangle, and you can say, wait, Professor, now you're into a right triangle, you could use for sine this definition. Place the opposite over the hypotenuse. And guys, if I place the opposite of the hypotenuse on this right triangle, I'm placing what? H over B?
Yeah.
Okay, opposite over hypotenuse. And we said angle A. Does everyone agree? That's sine of angle A. Now jump to the other right triangle over here, and now express sine of angle B, opposite over hypotenuse, and it looks like that would be H over A. See if you guys agree. Is it true? We'll do something nice here. Let's close down. I am going to go back, Ignacio, and clean this up a little bit. I'm going to just multiply both sides by P and make that first statement look like this. And the second statement, for a reason, will make it look a little better. Multiply both sides by A and have this. Are we okay? Now what do you think I plan to do? That's step one. Step two, what do you think I plan to do when I was asked to find this?
Replace H by.
Thank you, we'll do a substitution. So we'll go back to right here, that's my area at this point. I say, hold on, as Jacob's telling me, Professor, the area is equal to 1/2 C. Now you're gonna replace that H, Professor, with either one of these. I'm gonna try the first one, B sine A. Right here for a substitution. Close that up. Please tell me what equals there. Could I have chosen for H the other?
Yeah.
There's another substitute for H I could have used. So I could have written it as 1/2, still got C there for my base. The other height H substitution was A sine B. Whoa. Now, I'm gonna close this down. Can anyone look at what I have and tell me in reference to my triangle? This one says you can find the area, Professor, by taking 1/2 the product of these two sides, in my case, these two sides, times the sine of angle A. Notice where angle A is located in reference to those two sides. Where is angle A located in reference to B and C?
Adjacent.
And no, it's not adjacent.
Opposite.
Where is it? No, it's not opposite. Scared me. There's B and C. Where's angle A?
Oh, it's in between.
It's in between. It's angle A right here in between those two sides.
Yeah.
Now, the other substitution was valid. Let's see what it says here. You could also find it by taking 1/2 of the product of these two sides, A and C, times the sine again. Sine of what? Angle B. Does B fall between these two?
Yep.
Yes.
Now, I don't have, there's a third way. And I'm gonna ask you to tell me what it looks like. I don't have it on the board right now. There's a third way I could express this. 1/2, let me use my black here. 1/2, definitely C. Can anyone tell me the other possibility? Now, if I started out with C, here's C. Have I used this one yet? We used this, haven't we?
Yeah.
What's left? Have we used this one?
Not yet.
I don't think we used this one. Could I use these two sides?
Yeah.
A and B, then times sine of what angle?
C.
C. Okay, then 1/2, and AB sine C. I'm gonna step back and look at this. C, oh, we have C already.
That C shouldn't be.
Gotcha. Hang on a second. These two made all kinds of sense here. Could I, though, the way it's working out, could I have used 1/2 AB sine C
Mhm.
as another possibility? I just want to put that in there right quickly. Trying to rush too fast. Yes or no?
Mhm.
Please tell me, are all three of those telling me 1/2 the product of two sides, and you get to choose the sides, then attach to it the sine of the included angle? Is that what's coming out? Okay. Now, if I want to find the area, I can use any of those versions. What I want to do to close down, so we can take a break, I'm going to write this out as this. I'll make sure things around just a little bit. We said, Professor, you could use that. Another way to get the answer, Professor, you could use this. And if the logic follows, looks like you could use this one. Let me make sure everything is written down correctly. You guys agree? Is that all three stated up there?
Yeah.
1/2 the product of any two sides times the sine of the included angle. Is that true? I'm gonna clean that up. If I clean this up, Matthew, I'm gonna multiply everything by 2 first.
So,
Tell the class what you get.
okay, so two cosines of sine A.
You multiply everything by 2. Am I doing this correctly? So we'll just get rid of that 2. Can I go through and multiply everything by 2?
Mhm.
Is that true?
Yes.
Now watch what's gonna happen as we take a break.
You divide this by.
We're gonna divide for a reason. everything by A, B, C, the product of both sides. Which is valid. And then clean up each one of them. If I clean up the first one, guys, B's cancel, C's cancel. I'm left with sine A over lowercase a. This one, A's cancel, C's cancel. I'm left with sine B over lowercase b. Cancel, cancel. I'm left with sine C over lowercase c. Is that true? Is that what I'm left with?
No.
Please tell me on the handout, is that the way I expressed what they call law of sines?
Yeah.
That's where it came from. That's the derivation. And they call this, they give a name to it, which we're not gonna have time tonight to do anything with it, at least you have it. That's the law of sines. Whoa, now what's that gonna do for me, Matthew? Monday, it's going to do for us this. If the triangle is not a right triangle, this one wasn't, I cannot use these definitions. So I've got to use something else to find a missing part, and what am I going to rely upon, hopefully? This. To solve one of these oblique triangles. Guys, take a break. We've got a lot done tonight.